Hey everybody, welcome to another wonderful teaching episode, and me going over how to the combined gas law. Excuse me. So the combined gas law is a mathematical formula. I'll bring it up here, and what it does is it shows how properties, and let me move this so you can actually see what we're writing here. It actually shows how the properties of a gas, pressure, volume, temperature, will change to compensate for a stress that's put on the system. And so here, what we have is we have one set of conditions. That's why it says P1. So whatever the first set of conditions are, so whatever one set of the conditions, it's going to have a pressure, it's going to have a volume, it's going to have a temperature. Okay. Now, what we can do is, for example, increase the volume. We can have the volume go up, okay, from this original volume. So if the volume increases, in order to maintain a constant here, that this side is going to equal this side, the pressure is going to have to decrease, or the temperature is going to have to increase, or some combination of the two. And so what this does is it sets up the way to calculate what the new pressure, volume, or temperature is going to be based on what's changing. So we can definitely change, we don't have to just change the volume. You could change the pressure or the temperature, and based on all of that, we can figure out what the new thing is going to be. This is contrasted with the ideal gas law, because the ideal gas law shows, let's say PV equals nRT. The ideal gas law shows how what one of the conditions is based on knowing the other conditions. This shows how the conditions change when we're changing conditions. So this is if the conditions are constant, we are trying to find one of the conditions, temperature, number of moles, volume, or pressure, this changing. Okay, so in this problem we have three different parts. Okay, so we have where we want to heat the gas, we want to reduce the volume, and here we're going to inject additional gas. But here we also want to finish reading the question. It says indicate how each change affects the distance. So we have so we want the distance between the molecules. Okay, distance between molecules. So that's the first one. The second one is the pressure of the gas. And the third one is the number of moles. Okay, so let's take a look at A. Okay, it says we have a piston. So I guess before we do this, we better describe what a piston is. A piston is a cylinder that's got a cap on the inside of it, and then that cap can be pushed up and down. And this is what happens in an engine. Okay, this is how you turn chemical energy into mechanical energy, is that this piston goes up and down based on what's happening inside here. There's the little explosions. But anyways, the point is that this can change. You can either push on it, keeping all of this same the same number of moles, and that's going to increase the pressure, or you can change the volume, whatever, however you want to do it. Okay, so that's kind of what a piston is. And for all of these, I think that we can keep the formula V1P1 equals T1, over T1 equals V2 P2, I don't know why I'm having a hard time writing this today, over T2. Okay, so V1 P1 T1 equals V2 P2 T2. Okay, so what we're doing is, for the first one, we're increasing the temperature at constant pressure. So because it's a constant pressure, we don't have to worry about the pressure term. So I'm actually just going to erase that right out of there. So now the temperature is going to increase. Okay? So now the only way that, in order to compensate for that, the only thing that can happen is the volume will have to increase. Okay, as the temperature changes, the volume is going to have to change. So let's see. So for part A, let's answer those three parts here. So the pressure, that's going to stay constant, and the number of moles for the third part, that's going to stay constant. We're not changing the number of moles. Okay, but the distance between the molecules, as these molecules get heated up more and more, okay, they're going to need more space to move around because they're moving faster and faster and faster. As they need more space to move around, the volume of the container has to increase. And so the distance between the molecules is going to increase. So for part B, it says reduce the volume, okay, keeping the temperature constant. So I'm going to go and I'm going to, again, look at my V1 P1 over T1 equals V2 P2 T2. Okay, and so now we're decreasing the temperature is being held constant, so we're gonna ignore that. Okay, and so now the volume is going to decrease, so the pressure has to increase to compensate. So what's going to happen between the distance between the molecules? The distance between the molecules, as we change the volume smaller, now we are going to push those molecules in this piston closer together. Okay, they're going to have to get closer together in order to occupy a smaller volume. Okay, now what's going to happen to the temperature, the pressure? The pressure is going to have to increase because now we're taking molecules that want to have a certain amount of space, and we're going to push them in a smaller space. So that is going to change and increase the pressure. And then the number of moles of gas, that's going to, again, stay the same because we haven't done anything. Okay, so now for part C, it says inject additional gas. So what we've done is we've increased the number of moles. Notice that that's what this is. So that one we already know, that third part, N, has to increase because we've increased the number of moles. What's going to happen? V1 P1 over T1 equals V2 P2 over T2. Okay. What's going to happen if we increase the number of moles? Well, by increasing the number of moles, that increases the pressure, which is then going to and that's what's going to happen, is that the pressure is going to increase because now you have more molecules in your container occupying the same amount of space. So as they occupy the same amount of space, the pressure is going to increase and the space between the molecules is going to get smaller because now you have more molecules occupying the same amount of space. So this is all crazy stuff, but this is what the ideal gas law, or the combined gas law, gives us. Now we can do some mathematical things with this, and this is more like the types of things that I like to do. Okay, we have our calculator here. Okay, so we have a balloon. I mean, this is where you can laugh. So we have a balloon. Okay, woo! And that balloon has a volume of 6 liters and is at a pressure of 1 atmosphere. Okay, and it is allowed to go up. So the little kid releases it and cries. Okay, until the new pressure. So this is the old, and this is the new. So the new pressure is 0.45 atmospheres. And we'll notice that the temperature also changes from 22. Okay, from 22 to negative 21 degrees Celsius. Okay, so we want to know what its final volume is. This is a perfect example. Now I'm going to put my calculator back up here because I want this space. Okay, this is a perfect example of V1 P1 over T1 equals V2 P2 over T2. Okay. Now, what is our volumes? Our volumes are in liters, so this is 6 times 1 over, now we have 22 degrees Celsius. We can't use Celsius. We have to use Kelvin, so we're going to do 22 plus 273, and so that's going to be 295. So that's over 295 equals the new volume, whatever that is, times the pressure, 0.45, over the temperature, which is negative 21 plus 273. Okay, we get over 252. So now we do the math here. So we do 6 times 1. You don't have to multiply by 1, but in these videos I like to show all the steps here. Okay, divided by 295. Okay, and so now we're going to multiply both sides by 252. Times 252. Good. And then we're going to divide both sides by 0.45. And so we get our volume equal to 0.4. Oh, wait. Helps if I do the actual math. Okay. So we get 5.125 divided by 0.45. Okay. So that is the new volume is 11.39 liters. So that balloon has almost doubled in size. Okay, does that make sense? Well, there's less pressure. Okay, if there's less pressure, that means the balloon can expand. And there's less temperature. Okay, so that means the molecules aren't going to be moving as fast. So apparently this less temperature, cutting the pressure in half, is much more effective than reducing the temperature by somewhere around 40 Kelvin. Okay, and so that means that we're going to almost double the pressure. Okay, so that is how we do a little bit of ideal gas law, and have a great day.